that's being asked of a z-score, x minus the mean divided by the standard deviation. So that being the case, what information is given in the problem? Carl's z-score was 1. Plug that in. The mean on the stat exam was 74, but I don't know Carl's score. That's my x. The mean was 74. Of 77. And the standard deviation is 4. So I'm doing what you've probably done a lot, is to substitute numbers that are given into an equation. I substitute in the z-score. I don't know Carl's score. I substituted in 77 for the mean, which was given in the problem, and 4 for the standard deviation.
Do you multiply 4 out?
Multiply by 4. Who said that?
Sophie.
Sophie. Thank you, Sophie. All right, so I'm going to stick with you. You're going to multiply it by 4. What that does is 4 on the left, 4 times 1 is 4. 4 on the right, 4 divided by 4 is 1. It cancels out the 4, and you're left with x minus 77.
You add 77 to the 4?
You add 77 to the 4. So our next step is going to be 4 plus 77, which is 81. And that is Carl's score. Okay. You're breeding cattle. The mean weight is 1187. And then it says it's normally distributed. This notation gives you the first number is the mean, and the second number is the standard deviation. So it's normally distributed with a mean of 1187 and a standard deviation of 90. How many standard deviations from the mean would a steer weighing 1,000 pounds be? That's language for asking you, what is the z-score? Because the z-score measures how many standard deviations from the mean. So at the risk of this not being a problem, I'm going to do it again. Z equals x minus the mean divided by the standard deviation. You want to know the z-score. So the z-score is compared to a mean of 1187. And we've got to do this first on our calculator. Do this piece first. And then we have to divide by 90. And I'm going to do it on my calculator, and I'm inviting you to do it on yours and come up with a z-score. Negative 187. Daniela, thank you. All right, what are we going to do with the 187? Divide it by 90. And that comes up with a z-score that's not a whole number. What is the z-score that it comes up with?
Negative 2.07.
Negative 2.0, I'm going to say 77, okay? Because maybe it's rounding. Yeah. There's like 34 of you on my screen. Which one is more unusual? Now, you're not just going to say, well, this one weighs more, so it's more unusual. That's not the correct line of thinking. The correct line of thinking is, which one is further from the mean? And to find out which one is further from the mean, you need to calculate 2 z-scores. We've already calculated the z-score for the 1,000 one. Now we need to calculate the z-score for the 1250. So quite frankly, this is going to be kind of easy in terms of, so that's interesting, okay? This one has a z-score of 0.7. This one had a z-score of 2.08. This was 2.08 standard deviations from the mean. This one was only 0.7 standard deviations from the mean. So which one is more unusual? 1,000 pounds, let's recap. 1,000 pounds was 2.08, yes. And the 1250 was 0.7. This one was 2.08. This one was 0.7. So it would be the one that is, and I can't even get to there.
Oh, it's more unusual. I was reading it
More
wrong.
unusual, okay? More unusual would be the 1,000 pounds. It had the bigger z-score. It was further away from the mean. This one's two away from the mean. This is only 0.7 away from the mean. They all have a center of 25.8. So that's not going to help us. But if I take 25.8 and add one standard deviation, 6.2, I get the number 32. So I'm going to pick one that has a marker of 32 just to the right of it. Is it this one? No. Is it this one? No. Is it this one? Yes. So by process of elimination, without doing all of the markings, by process of elimination, I know this is the correct answer. Now that we know this is the correct picture, in what interval will you find the middle 95%? 95% is in between what two numbers? 13.4 and 38.2. So you have to do part A before you can do part B. Part more than 32. Okay, the more than 32, there's a couple of ways we could do this. We could think about it, or we could refer to our cheat sheet, or I can use this. Okay, so if it wants more than 32, if it wants above 32, you could add the 13.5, the 2.35, and the 0.15, and you would get 16. So if you had your little sheet, that would be an easy way around it. Now I'm going to go back to the problem, which we now know the answer is 16. Okay, now here's where you really, really want to use that sheet. Elementary school children come in different heights. They are normally distributed with a mean of 39.2 and a standard deviation of 1.9. What fraction would we expect to be less than 35 inches tall? So I want less than 35 inches. One way we could do it is to compute a z-score. So you're going to, for problems that involve the normal curve, you're going to go to Get More Help. You're going to pick StatCrunch. you're going to go under Stat, Calculators, Normal Calculator. And there's your normal calculator. You will notice that the default is 0 and 1. The default is the standard normal curve. This is the default, which wants a z-score. I'm going to bypass calculating a z-score. Make life easy. I'm going to give the calculator the mean in the problem. The average kid's height was 39.2. The average kid's standard deviation was 1.9. I want to know what percentage of kids are shorter than 35 inches. Completely changed my input. Not using the standard normal curve, using the information as it is in the problem, not calculating a z-score. Do I get pretty much the same answer? Yep. This is, if I convert to a percent, it's 1.35. Pretty much the same answer. It only differs in the fourth decimal place. The middle, 60%. I'm writing this down, the middle 60%. Calculator's normal. Okay, I didn't calculate any z-scores. I want life to be easy. So I'm going to change this mean from 0 to 39.2. The mean in the problem. I'm going to change this to 1.9. Less than or equal to isn't going to work for me. I want in between. I'm going to change it to in between. Now, they gave me a percentage. They want the middle 60%. So we are working it backwards. We are given a percent and we want to find the heights. So in here, I put a 0.60. Change from standard, which is less than or greater than, to between, which is going to give you some boundary values. The middle 60% and compute. Okay, so what about these kids? They're between 37.6 inches and 40 point, well, they're going to ask for rounding, 799. So if they want one decimal place, it's 37.6 and 40 point. This gets rounded up to an 8. 40.8 if they want one decimal place.